Does filtering noisy robot feedback actually improve closed-loop tracking? It sounds obvious, it isn't. Filtering removes noise, but it also adds lag, and in a feedback loop, either effect can dominate. So it's an empirical question, not an assumption. This is the actual scene on the actual simulator build. A Franka arm in Isaac Sim, sensor noise, and a 25 Hz vibration are injected on the feedback path. A causal filter, or an explicit pass-through, feeds a waypoint controller. The build is a release candidate. General availability was never evaluated. Before any of that could be measured, the runtime had to be verified. The scene's static contract check passed. Then, on the actual Isaac Sim runtime, 0 joint state messages were published. A file can be structurally valid while the running system does nothing. The second problem was worse because it would have produced numbers. The signal path was designed for 200 Hz. The default runtime sampled at 30. That puts Nyquist at 15 Hz, below the 25 Hz disturbance, which folds down to 5. The filter's cutoff is also 5. And because both arms shared that boundary, the comparison itself would not necessarily have exposed it. The sampling boundary was corrected, and nothing else was. Nothing was retuned to make the result look better. Then the design was frozen 20 seeds, 2 conditions, 40 runs, the manifest hashed and committed before the first run executed. One pair is shown next. To avoid picking the most flattering one, it was chosen by a rule fixed before plotting. And this is what the campaign actually recorded. One preregistered pair, straight from the committed telemetry. On the right, the pass through the disturbed joint, state measurement reaches the controller unchanged. Across all 20 pairs, filtering improved tracking in every one. Measured at the arm's true position, the improvement is smaller, so both numbers are reported, not just the more favorable one. Now the part that's easy to leave out. 40 runs were valid, meaning admitted under the frozen contract. 0 of 40 passed the acceptance gauntlet. The filter did what it was designed to do. The controller did not meet its targets, and those thresholds were not relaxed afterwards. The result is useful. The stronger result is the process that caught invalid experimental conditions before they could become evidence. Everything you just saw is checkable. The frozen manifest all 40 runs, and the analysis that regenerates every figure are committed in the repository. If you doubt a number in this video, go check it. That is the point of building it this way.